Hi, seventh graders. We are going to go through lesson 7.1.5 today. This lesson is about creating integer coefficients, which is actually review. We have done this when we were solving for x. We just touched on it, knowing that we are going to come back to it, but today we're going to dive a little bit deeper into it. So the first problem, and this is on the document that I also attached, so you can have it up. So hopefully you're able to read the problem yourself rather than relying on just my voice. But I will read it to you. It says, the Community Service Club is planning to paint apartments at the local senior citizen center next week. The club needs your help to determine how many apartments they should be able to paint in a day. Earlier in the year, when only 4/7 of the students worked, they painted 9 apartments in one day. Next week, all of the students are going to be available. So what we're looking for here is how many apartments will the club be able to paint? Things that we are assuming here is that they are painting, each person paints the same amount, that they're painting at the same speed. So we have to think about what it is an equation that we would write here. So we are looking for 7/7 x. We're 100% of the kids are there. That's 7/7, which is 1x. So we're trying to solve for x. The equation that we're trying to solve now is 4/7 x is equal to 9. Okay. So we're looking for how many apartments the club should be able to paint. So we have to solve this problem. Now, if you went through the Pear Deck presentation, you learned some strategies that you can do. The one that we talked about in class and that I think most people are going to rely on that really works for them is multiplying by the coefficient's reciprocal. Remember, the coefficient is the number in front of x. So it is the 4/7. So in order to get what 1x equals, we're going to multiply by the coefficient's reciprocal. Now remember what that does. Anytime you multiply a number by its reciprocal, you always get 1x, which is what we're looking for here. So we're going to multiply both sides by 7/4. Okay, this is a giant, super giant one. We have to multiply this side then by 7/4. And remember that 9 is over 1, not over 9. Then you get 63/4. Now if I divide 60 by 4, I get 15. Then I have 3/4 left over. So I end up with x equals 15 3/4, or x equals 15.75. Okay, so this is the first problem. Now, maybe you struggled with putting that word problem into an equation, and then once you got to this equation, hopefully it kind of started to come back to you, but this is what today's lesson is making integer coefficients to be able to solve for 1x. Okay. The next problem is solve for x by eliminating the fraction. And in this question, we have 2/3 x is equal to 8. So 2/3 x is equal to 8. Okay. So this is what you guys are trying to solve for. Solve for x. All right, so the way to solve this, here's our coefficient. We need a full x. So we need to multiply both sides by a number that'll give us a full x. We know that the way to do that is by multiplying by that coefficient's reciprocal, which is 3/2. And this works because 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1. Okay, we can't just do that to one side, we have to do that to the other. So we're going to multiply this side also by 3/2. Okay, that's over 1, if that helps. Keeping in mind the way we would multiply fractions is we multiply right across. So we have 8 times 3, 24, 24 over 2, and 24 over 2 is equal to 12. So x equals 12. Okay. Question 3. Okay, we have Jason who's buying a video game that was marked 15% off, and the sale cost is $36.21. He wrote the following equation, okay, 0.85x is equal to 36.21. First question, where did that 0.85 come from? Okay. is there a number that you can multiply both sides of the equation by to get an integer coefficient? Okay. And how much did the original video game cost? Okay. So here's our equation. Okay. Now the first question was, where did that 0.85 come from? Well, if it's 15% off, okay, he's going to have to pay 85% of the total of the original cost. That'll be his sale price. So the 0.85 came from the percent that is still left to be paid after the 15% discount is taken off. Is there a number you can multiply both sides of the equation by to get an integer coefficient? Well, this is kind of like when we are dividing decimals, right? We don't like to divide with decimals, right? They can get in the wrong place, they can get forgotten. So the goal here is to multiply both sides by a number that'll cancel out the decimals. The nice thing about this is they both have the same amount of decimal places, 2. So what number do we multiply that'll end up moving the decimal place over 2? 100. Okay, so multiplying both sides by 100. Okay, we're going to multiply both sides by 100. That basically eliminates the decimal places. So we end up with 85x equals 3,621. Okay, so now we've successfully eliminated the decimal places. Now at this point, we can divide by the coefficient. That coefficient is 85. So I'll divide both sides by 85. Okay, so notice now here's our giant 1. Whoop, there it is. And then we have to do some long division here. Okay, so once we do some long division, you should get $42.60 was the original cost of the video game. Okay, so long division. If it's still giving you some trouble, reach out to me. Also, now that you guys have your usernames and passwords to iExcel, you can pretty much find all the 7th grade skills in there, and they can give you some practice problems, as well as the explanation of how to solve it if you get it incorrect. So that's going to be a really valuable platform for you guys. Okay. Then question 4 is just some practice. So we have 5/6x equals 4. Okay. What should we multiply both sides by to get a whole x? The reciprocal of the coefficient, 6/5. Doing so, we get a giant 1. So we have 1x, okay? And then we have to multiply the other side of the equation. And remember, 4 can be written as 4 over 1. If we write it as 4 over 4, then that's just 1, okay? And that would be changing the equation completely. So it's going to be 4 times 6 to get 24, and then 24 over 5, okay? So that is not as meaningful as if we turn that back into a mixed number. So we are able to pull out 4 wholes, okay? Pulling out 4 wholes, we use up 20 of the 24. So we have 4, and then we have 4 left over. So that's 4/5, which is the same thing as 4.8. So the first question is 4.8. Okay. Second question, 0.8x. So basically 8/10 of an x is equal to 19. Okay, this is our problem. We need to figure out what we can multiply both sides of the equation by that would get rid of that x. Now, we can't just move it over 1 on one side of the equation, not the other. So we need to multiply both sides of the equation by 10. Doing so is the same thing as just moving the decimal place over 1. So I'm just going to show, so this doesn't get lost here. Okay, I'm going to multiply both sides by 10. Okay, because 8/10 times 10, okay, we got just an 8. So 8x equals 190. Okay, Then we have gotten rid of our decimal places. Now it's just solving for x. So we need to divide by 8, which is the coefficient. And what we do to one side, we have to do to the other. So 190 divided by 8. And again, a little bit of long division here. So I'll show this one. So 190 divided by 8. Okay, making sure we have the divisor and the dividend in the right spot. We ask ourselves, how many times does 8 go into 19? And that answer is just 2. Okay, and then we multiply. 2 times 8, okay, gives us 16. Okay, we subtract that, and then we have 3 left over. Then we bring down the 0. Okay, so we're at this point. How many times does 8 go into 30? Okay, that is 3. And then 3 times 8 is 24. We have 6 left over. Okay, and in the past you've wrote remainder 6, but we're past that. We know that we're going to take those 6, remember cheese sticks, we're going to break them up into tenths. Okay, so I'm going to put a decimal place in both the 0.9 and above in the 23. And I'm going to bring down a 0. So now I have, how many times does 8 go into 60? Okay, and that is 7. Okay, 7 times 8 gives us 56. And we have a remainder of 4. Okay, then we can bring down another 0. And how many times does 8 go into 40? 5. Exactly 5. And then at that point, we have nothing left over, and our answer is 23.75. Okay, so the answer to the second question is, there it is, 23.75. Third question, question C, is 5 6x equals 12. Okay, what number do we have to multiply both sides by to cancel out that fractional coefficient and to get us to a whole 1x? Okay, yep, we have to multiply both sides by 6/5, just like we did in the first problem. Okay, and we're at this point. Okay, 6 times 5 is 30, 5 times 6 is 30, 30 over 30 is 1x. So we have successfully gotten down to 1x. Okay, and now we do the other side. Okay, let you do that. 72/5. Okay, again, not meaningful until we go ahead and simplify. Okay, so how many times can we pull 5 out of 72? Okay, so, or you can do some long division here. Good time to do some long division. So 72 divided by 5. Okay, 5 goes into 7 just one time. Subtract 5. You have 2 left. Bring down the other 2. Okay, that's 4. 5 times 4 is 20. You have 2 left. Okay, and this is the part where we're not just saying we have 2 left over and we're throwing them away. We put the point in after the 72 and after the 14, and we bring down a 0. And how many times does 5 go into 20? Exactly 4. Okay, and at that point, we are done. 14.4. Okay, and the final question, 0.12x equals 1. Okay, so 12 hundredths of an x is equal to 1. Again, our goal here is to figure out how to turn our decimal coefficient, okay, into a whole integer coefficient, and we want it to be 1. So first thing that we want to do is get rid of the fractional or the decimal coefficient, and we would have to multiply both sides by what number? Yep, 2 decimal places means we're multiplying by 100. Multiplying both sides by 100. Okay, we get 12x equals 100. Okay, here I'm going to show my work. Okay, multiplied both sides by 100. 12x equals 100. And at this point, we do the division again. Okay. Okay, then we take 100 and we divide it by 12. Okay, so I'm going to let you do this one. Okay. Okay, so we are going to ask ourselves, does 12 go into 10? No. So we have to figure out how many times does 12 go into 100. Well, we know it's going to be less than 10, right? So we can maybe try 8. So we take 12 times 8, okay, and we get 96. That's pretty close. So we're going to do 8, and we have 96, and we bring down the 4, or we have 4 left after we subtract. Okay, and then we're going to add our decimal places and our 0. Bringing down the 0, we're at 40. Okay, so how many times does 12 go into 40? Okay, that's 3, right? 3 times 12 is 36, so 3. 3 times 12, I said, was 36. Subtract that, and we have a 4 left over. And at this point, hey, I had 4 before, so I know it's just going to keep repeating. I'm never going to get rid of everything. So this is a repeating decimal, and x equals 8.3 repeating, which is 8 1/3. Okay, so today was review of solving for x when there's a fractional or decimal coefficient. Again, this is also an opportunity to practice IXL. And in any free time, if you zoom through a lesson and you're like, oh, okay, now what? Prodigy and IXL are really going to keep you guys engaged and learning, and so you don't feel like you're like backtracking in the math world. So let me know if you have any questions, and we will see you tomorrow. All right, bye-bye.